So you can do this lots of different ways, and for example, you can see page 185 in the text. And I'm going to show you, I think, is the most straightforward way of doing it, with the least amount of writing. Okay, you're going to use the definition of the derivative, the same definition of the derivative we've been using. You just write everything out. And this is over h. But then I'm going to make an aside, and I have the benefit of color, but generically, and I'm going to use y just because I've used f and g already, but y prime equals, and this is exactly the definition of the derivative again for just a single function. So what I'm going to do now is I'm going to rewrite this by putting h on the other side and getting rid of the limit. I can do that if I use this approximate equal sign, so I'm going to multiply both sides by h. Okay, and then I'm just going to rewrite this. And you notice when I'm using y of x, I'm going to drop the y of x. I'm just going to make it y. But if it's y of x plus h, I'm going to write it all out. That's what I mean. So y of x is just y. Okay, just to save writing. Okay, so if I want to write y of x plus h, I write y prime h plus y. And so I'm going to replace f of x plus h and g of x plus h with these shortcuts. And I'm going to just come over here and just use the same notation, but now with f and g. Okay, that's it, right? And now I'm going to just put it all together and it will just work. So I'm going back to blue, which of course you can't do unless you bring colored pens or something. So this is limit as h goes to 0. And one thing you can do, if you don't like these fractions, you can just put the 1 over h and then put all your garbage inside parentheses. Okay, so that's what you get. You get, so where we had f of x plus h, that's now replaced with f prime h plus f. And where we had g prime x plus h, we replaced it with g prime h plus g. And then fg is just fg. Okay? And then this over h is just over here. Great. So now let's see what happens. Okay, so we have it's 1 over h. We're going to expand this using FOIL, or distributively multiplying. So for the first piece, you get f prime g prime h squared. This is that famous piece that you always think is important, but it turns out not to be important. But it is true that f prime and g prime do meet at some point. This is where they meet. Then we have outer f prime gh, and then inner f gh prime, and then last plus f times g. Now, because I'm getting rid of all these parentheses anyway, I'm just going to say minus fg. So this guy, fg, is going to cancel with fg. And this h is going to cancel with this h and this h. And one of those h's is going to go away. We now allow h to go to 0, so this piece gets wiped out. Almost looks like football. Okay, so we get f prime g plus fg prime. Okay? Very easy. Now, the next thing we need to do is use the product rule to take a derivative. So we're going to let this be x times e to the x. You don't have to set this off in parentheses, but I'm doing that for clarity. So y prime is first times the derivative of the second plus the derivative of the first times the second, and however you want it. As long as the pieces end up like that, that's fine. You're not required to show your work like this, but it's one of these things where if you mess up, it helps you salvage your points. That's a totally fine answer, so we're done. But if you wish to factor out the e to the x, I have the urge to do that because I've done enough of these problems where I have to do it. But in this case, we don't need to take the last step. Okay.